Hello everyone, today we will learn Newton's law of motion regarding JEE Mains and Advanced and NEET also. So in the first part you can see it for NEET, but in the second part we will mainly focus on JEE Advanced. So let's start. Before going through this lecture, make sure that you have watched our previous lectures uploaded in YouTube for Newton's law of motion for both level. So let's start. Newton's law of motion. See, in motion we have three types of forces mainly. One is field force. So field force means there is no contact. There is no contact. If we consider the rotation of Earth, around Sun, so there is no contact. There is no physical contact. So we can say that there is a force, gravitational force. There is a gravitational force between Earth and Sun, by which the objects are, by which the Earth is revolving around the Sun. So there is no physical contact. So we can say that gravitational force is a field force. Another field force is our electrostatic force of attraction. Let us say we have positive charge, two positive charge, Q1 and Q2. So there is a Coulombic force, that is F equals to K into Q1 Q2 by R square, where K is 1 by 4 pi epsilon naught. So we will learn it in details in class 12, but see here also there is no physical contact. This is the distance, this is not the contact, this is the distance between two charges. So let us say here F and here F1 and here F2, let us say. So it is a Coulombic force. So there is no physical contact, so we can say that electrostatic force is our field force. Another field force is our weight. So let us say we have an object here in h height from the ground. So there is a force or weight act towards the center of the earth. So W equals to, we can say, mg, and that is our force. So in this case also there is no contact between earth and the object. In that case also this mg or W equals to mg is your force. So there is no physical contact, that means it is a field force. Another type of force is our contact force. So it is basically the attachment of two bodies or contact between two bodies. Let us say we have an object placed on the surface or the ground, and we know from the Newton's law of motion that if this object is acting, giving the force F equals to mg or W equals to mg towards the earth will give the equal force to the object, and that force is known as your normal reaction force. In some book they represent the normal reaction force as R, because M stands for Newton. So I think you can use both of them, that is N and R subsequently. And if this surface is rough, then we know that there will be a frictional force. If you apply a force towards the right hand side, there will be a frictional force in the left hand side. So our contact force, if you observe closely, that this frictional force and this normal reaction force is actually perpendicular to each other. If this is perpendicular to each other, then we can say that the resultant force, F is actually your root under of F square plus N square. Why? Because we know that if there is an angle between the two vectors, let us say A and B, theta, then we know that the resultant force is, let us say this is F1 and this is F2. Then resultant force is F1 square plus F2 square plus 2 F1 F2 cos theta. Now in this diagram we can clearly see that frictional force and normal reaction force angle is 90 degree. So cos 90 is 0. This term will be omitted out. So the force would be root under of F1 square plus F2 square. But here in this case F1 is small f, frictional force, and reaction force is capital N. Let us see other examples. If we have two objects connected something like this, and if we apply force capital F1 in the upper objects and capital F2 towards left side in the lower object, that is on the object B. If we draw the FBD, that is free body diagram, we can clearly see that this object is acting, this object A, the block A is giving force W equals to mg towards block B. So that's why that block B will also give equal and opposite force upward, that is Newton's third law. Let us say that reaction force is N, and in the right hand side for block A there is a force F1 in the right hand side, and if you move that object towards the right side, then our frictional force for the upper object will be in the left side. Let us say that force is F. And if you draw the FBD free body diagram of the lower object, in this object we can see that we are trying to move that object in the left hand side. So for this object our frictional force will be in the right hand side. And if you clearly see that here is also we are applying Newton's third law of motion. This is action reaction, equal and opposite, action reaction, equal and opposite. That's why this small f is same. And in the left hand side we are applying force capital F2, and if this block is giving reaction force N, and so this block, capital A block, will give the same equal and opposite force, that is N also. Okay, that's how we can draw FBD. Now in the subsequent category we can say that there is another type, that is attachment to another body. So there is no direct these two blocks are not directly attached but attached by a string. So if the two objects are attached by a string, see in this pulley system here is also the two blocks are attached by a string, and in this scenario the two objects are attached by a string. So if we apply force F in the right hand side, if we let us say capital M, here in this case let us say capital M is greater than small m, so the object, the system will move in the right hand side. So let us say acceleration is A, and if this object, if we apply a force capital F, so acceleration would be A. Always remember, if this string, this is the same string, this is the same string, if this string is inextensible, the acceleration of the combined system would be same. If this string is inextensible, the acceleration would be same. That's why if this object, this block have acceleration A towards downward, that means this object is going upward, so it will have the same acceleration A. If we apply F force in the right hand side, if that block have acceleration A, now we have seen that if this string is inextensible, then the acceleration of this mass will also be A. So let us continue our attachment to another body. See another number 2 point. If a string is massless, the tension in it is same everywhere. But if the string has a mass, then and it is accelerated, tension will be different. This is extremely important, but these 3 points are extremely important. Kindly notice to these points. So if the string is massless, the tension will be same everywhere. See, this is the case. Here two bodies are attached with the pulley system, and the mass of this is small m and this is capital M, let us say. Here we have assumed that string and pulley, both of them are massless. String and pulley, this is pulley and this is string. This string and pulley, both of them are massless. That's why if you have noticed, this tension is same. This tension is same. And in the board level lecture, I have already told you how to find these tensions. Always remember, tension is towards the pulley. Tension is towards the pulley. So if this tension is towards the pulley, then it will have a reaction also. If this is the action, there will be a reaction also. The pulley will give a reaction, that is T. So if this tension is towards the pulley, then pulley will give a reaction T. Why this is, the whole thing is as T? Because see, this string is same. If the string is same, the tension will be same. And in this case, we have assumed that string and pulley are massless and there is no friction between pulley and string. Now in the third point, if pulley is massless and frictionless, tension will be same on both the sides of the pulley. This is the case. See this case, if string is massless, this string is massless, but pulley is not massless. Now in this case, pulley has some mass and frictionless. That means this pulley and rope system is frictionless, but pulley has a mass. This rope has doesn't have any mass. In this scenario, you will see that in this part the tension will be same, that is T1 and T1, and in the other part this tension will be same, that is T2 and T2, but throughout the string the tension will not be same. See the third case. In this case, string and pulley are not massless. That means string has mass and pulley has mass, and there is a friction between pulley and string. Also, with adding the concept, the string and pulley has friction also. So in this case, our tension will be different. That means action and reaction, this T3, T4, all these will be different. See, in the first case, it is in your JEE mains and for NEET. In the second case also it is for JEE mains, and third case is strictly for JEE advanced. Now we have another type of force, our last type of force, which is hinge force. Let us say we have a hinge. By this hinge we have attached a rod and we have a string connected to balance the rod. Now in this figure, if you observe that this string is holding this rod, so this string, this hinge holding that rod, so this hinge will have two forces. You can resolve this hinge force as horizontal force and vertical force. So we will see some examples regarding this concept, and this last concept is actually for advanced. So let us see some important notes. Normal reaction is perpendicular to the common tangent direction and always acts towards the body. That means this normal reaction is always acts towards the body. If you observe this picture we discussed in the earlier pages, so in this block the normal reaction is towards the body. So we denote this as this, but actually this thing is towards the body. Now it is just like a pressure force. So see, we know that pressure is force per unit area, so that means force will be pressure into area, and it is the pressure acting perpendicularly towards the object. Now if you see this system, this ladder, if you see this system and it has friction in the wall and the surface in the horizontal, then see in the upper surface, in the upper side where it is touched with the vertical wall, it will have a normal reaction force. Let us say this is N2, and for the horizontal surface or for the in the ground, it will have a reaction force by the ground towards the object. That means it will have a reaction force N1. This surface and this surface are different, that's why reaction force is also different. Now let us see this diagram. In this diagram we have denoted various string forces with different names. Let us say this is T1, T2, this is T3, T4, T7, T8, and this is T5 and T6. So this T1 goes to block A, that is force applied by the string on the block A, because action and reaction are same, equal and opposite. So this T1 is away from the block, Now T2 and T3, this T2 and T3 is for the pulley, to the pulley P1, and this T4, T7, T5 is to the pulley P2, T8 is to the block B, and this T6 is for the roof. In this scenario, if string and pulleys are massless, this is one string, this is one string. So let us see, in this case, if this string, this is one string, right? This is one string. This string is whole one string, and this is another string. If this string has, this string is massless and there is no friction, if we assume that we have already seen in the previous slide that if the string is massless and the pulley is massless and frictionless, then this tension will be same. So here in this case, if this as this string is one string, so T1, T2, T3, T4, T5, T6 will be same, and this is another string. Remember, this is another string, that is why these two forces, these two tension forces will be same. Now let us see another note. If a string is attached with a block, then the force is away from the block. The force is away from the block. This tension will be away from the block. Remember this. And if the block is attached with a rod, here is a string is attached with a rod, then it will have only a force away from the block. But if it is attached with a rod, it is a rod here. This is a rod. So if this block is attached with a rod, it will have a push and pull force. So let us say this is a push force and this is a pull force. If we apply Newton's third law, this push and pull force will be equal. Now we will see FBD. So let us see some FBD. In the board level lectures, we have already discussed how to draw FBD. FBD means free body diagram. That means we have to separate the objects attached with each other, and you have to show individual forces attached to that body. That is all about free body diagram. So we have a object, let us say this roller in this V-shape surface. So in the circular shape objects, we know that center of gravity is at the center of the circle. So weight, this weight, the whole object weight will act towards the center. So and weight is always downward. So W is toward from the center towards the ground, that is W, and reaction force is always perpendicular to the surface attached. Always remember, reaction force is, or normal force is always perpendicular to the surface attached. So that means this surface and this reaction force will be normal or perpendicular to the surface it is attached, and it will have a reaction force here also. Let us say this is N2 and this is N1. So let us say let us see this arrangement A, B, C. There are three blocks, one is above another. So we have separated three blocks A, B, C separately. Now let us see, if you see this object, this surface will create a normal reaction force, and we know that normal reaction force is towards the object, right? So let us say this normal reaction force is N3, and this block C is giving a force W, let us say WC, towards the ground. This surface, this B block has weight towards the downward. So let us say this is WB. So let us say, okay, let's see the last block. So this is our C block. In the C block we can see that weight is acting downward, this is WC, and we have a normal reaction force for this surface. So this is N3, and for this surface we have a equal and opposite reaction force, right? So this block is giving a normal reaction force towards C. So this normal reaction force will be towards the object. Normal reaction force is always towards the object. So that means for this object, normal reaction force will be towards that object. So N2, and this N2 will be equal and opposite for B. So this surface will give equal and opposite reaction force to that object B. So that means towards the object. That means this N2 is upward. Weight of the B is downward, and for this surface normal reaction force is towards the downward, that is N1, and for the upper surface we have this N1 in the upper side, and we have weight WA downward. So that is all about FBD. Now let us see this arrangement. We have something, this arrangement, there is a block attached with the ceiling, this. So this string and this string are different, that's why tension is away from the object. So this tension, let us say T1, and this tension is, let us say, T2, and it will have a weight mg downward. That's how we draw FBD. FBD means free body diagram. That means you have to free all the body and you have to see all you have to mention all the forces acting on that body separately. That is known as free body diagram. So let us move to our next topic, which is equilibrium. So in the maximum number of cases to solve a problem, we will apply this concept, that is when any object will be in equilibrium. To be equilibrium, you have to first see what is the resolution of a force. Let us see, we have a force F1 and we have a force F2 here. So according to if this is the angle between, let us say, F resultant force and F1, then this F1 would be F cos theta. From the vector concept we know, if this is A, this is B and this angle is theta, then A equals to B cos theta. That is our component of force along component of B along A. If we want to find component of A along B, then it should be A cos theta. If this is A equals to B cos theta, then our perpendicular component would be perpendicular component A sin theta. So according to that concept, the angle attached to the surface is your cos component, that is F is attached to this F1 with the angle theta, then it should be cos theta. So F1 is F cos theta and this perpendicular component would be F sin theta. Now let us see 1 to 2 question. Resolve a weight of 10 Newton. Resolve a weight of 10 Newton in two directions which are parallel and perpendicular to a slope inclined at 30 degree to the horizontal. So let us say we have an inclined plane. This is our inclined plane which is 30 degree, and we already know from the basic concept that weight is always towards the horizontal surface, perpendicular to the horizontal surface. That means this weight, the weight of this block, is perpendicular to the horizon. So this weight is given as 10 Newton. This weight is given as 10 Newton, and this, the perpendicular component of this weight is this, because you see this is perpendicular to that surface where the object is attached. So this is your perpendicular component and this is your parallel component. This will be your parallel component. If this is angle theta, this is 90 degree, so this angle would be 60 degree. Now as this and this are perpendicular, so if this is 60, this will be 30. So always remember, if this is 30, this angle will always be 30. And if you notice, this is the perpendicular component or this is the cos component, we can say this is your W cos 30 degree, because W is attached with angle 30 degree with that component, and this is your perpendicular component, so this would be your W sin 30 degree. So our perpendicular component would be W cos 30 degree and our parallel component or sine component would be W sin 30. Now put the values 10, you will get 2. Now we will see another question. So let us see one problem. A body is supported on a rough plane inclined at 30 degree to the horizontal by a string attached to the body and held at an angle of 30 degree to the plane. So to the body and held at an angle of 30 degree to the plane. It is held at an angle of 30 degree to the plane. Draw a diagram showing the forces acting on the body and resolve each of these forces along horizontally and vertically and parallel and perpendicular to the plane. So you have to resolve here in the two times. One is for this plane, one is for this plane, and one is for this horizontal surface. So let us see first for this horizontal surface. If you look closely, if we draw a parallel line, then this is the transversal. If this angle is 30 degree, then this angle should be 30 degree. So from this line to this line to this F, this is your F, frictional force is acting backward, because we have applied a tension force in the right hand side with an angle of 30 degree. So that means if this angle is 30 degree, this angle should be 30. So if this angle is 30, then this component would be F cos 30 and this component would be F sin, perpendicular component would be F sin 30. Now let us see for this normal reaction force. Now see, this is 60 degree and this total angle is 90 degree, so that means this angle should be 60 degree. If this angle is 60 degree, so that means this normal reaction force is making 60 degree with the horizontal, this horizontal. So see, this is your normal reaction force and this angle is 60 degree with the this horizontal. So this is 60 degree. So now our attached component will be n cos 60 and our perpendicular component will be n sin 60. Now let us resolve for t. Now this is your angle 30 degree, this is your angle 30 degree. See, if this angle is 60 degree, if this angle is 60 degree, then this is your 30 degree, and if this is 30, then this should be 30. So 30 plus 30, that means this total angle with the horizontal is 60 degree. So t is making 60 degree with this horizontal. So our attached component would be t cos 60 and our perpendicular component would be t sin 60. Now see, here we are drawing this for this horizontal component. Let us say this is x, this is x and this is y. So according to the x and y axis, we can draw the components. So let us say force. We have 4 forces here: F, N, P and W, and W is always horizontal to the surface, right? Always perpendicular to the surface. So for F, if we see F, we have F cos 30 in the negative x axis. F cos 30 in the negative axis, that's why it is minus, right? And parallel to OY, if we see that F sin 30 is perpendicular, so in the downwards, so that's why it is minus F sin 30. For N, we see in the negative x axis it is n cos 60, that's why it is minus n cos 60, and in n sin 60 is in the upward direction, so it is n sin 60. For T, we can see that upward force is T sin 60, that's why it is plus in the OY, and in the right hand side it is T cos 60, that's why it is plus component. And if you resolve here the W, see, W is acting downward, so that means for vertical component our W is negative because it in the negative y axis, and for horizontal axis there is no horizontal component of W, that's why horizontal component is 0. Now if we resolve this diagram for parallel and perpendicular to the plane, that means this plane, now we have to consider this plane. Now for this you have to consider that your x axis and y axis are lying something like this. Let us say this is your OX prime and this is your OY prime. So that means now you have to resolve the component along the plane. That means we have drawn a new axis. This is our OX prime and this is our OY prime. Let us say this is our OX prime and this is our Y prime. Now if we look closely that this is our F, that means this is our F. So for F we have only negative x component, that is minus F, and there is no vertical component of F along the plane, so that's why we have OY prime as 0. Now if we look closely the component of N, that is N, so N is upward, so we have only vertical component N and we don't have any horizontal component, that's why we have 0 component in the horizontal along the plane, remember this. Now if we see the T, then see, this is T, right? This is your T. If this is T, this angle is 30 degree, that means in OX prime, that is in the positive x axis, it should be T cos 30. And what is the vertical component? Vertical component would be T sin 30. So it is in the upward direction, so that's why it is plus. And if we consider weight, now see, this angle is 30 degree. Now if this is W, then this is W cos 30 and this component would be W sin 30. So our W sin 30 is in the negative OX prime, so it is minus, and W cos 30 in the negative OY prime, that's why it is minus of W cos 30. So let us move forward to our next topic, which is moment of a force. See, it is the general name given for the turning effect. Any general name given for the turning effect is known as torque, we know, and the magnitude of torque is your what is known as moment of force. Moment of force, that is torque, can be calculated out as force into perpendicular distance from the axis of rotation. This is very important. Force into perpendicular distance from the axis of rotation. Let us say we have an object and this is your axis of rotation. The object is rotating around that axis. Let us say we have applied force F1 here in this direction and force F2 here in this direction in the object. That's why it is rotating. So if you kindly notice that F1 is anti-clockwise and F2 is clockwise. That means F1 is trying to move that object in anti-clockwise direction and F2 is trying to move that object in clockwise direction. And perpendicular distance from axis of rotation is R1 for F1, let us say, and F2 and for F2 perpendicular distance from axis of rotation is R2. In order to take the sign, you can take any sign, but in our lecture we will follow anti-clockwise torque as positive or anti-clockwise moment as positive and clockwise moment as negative. You can take clockwise moment as positive also, that is up to you, but follow the same convention throughout your career. So F1 R1, so let us say anti-clockwise torque, this is F1 is trying to move that object in anti-clockwise. So force into perpendicular distance. What is the perpendicular distance? R1. Now here force is F2 and what is the perpendicular distance? R2, but here we have taken clockwise moment as negative, so this is minus F2 into R2. Now what is zero moment? If the line of action of force passes through the axis of rotation, its perpendicular distance from the axis is 0, therefore its moment about the axis is 0. So if the line of action passes through the axis of rotation, this is very important. If the line of force, let us say this is the line of force, this is the line of force. So in that case perpendicular distance from axis of rotation would be 0. So for that thing our moment would be 0, because if perpendicular distance is 0, so 0 multiplied by F, so torque or moment is 0. Let us see one example. Here one square is given and the direction of forces are given. This is 2 Newton, this is 5 Newton, this is 4 Newton and this is 3 Newton. Direction of forces are given, center O is given. So and the length of each side is given as 2 meter. Calculate the moment of each force about an axis through A. That means in the first case we are passing an axis through A. That means our axis is something like this. Okay, it is going through A. And in the second case our axis is going through O. So in order to calculate torque or moment of force, we know we need the magnitude of force and the distance. Here the distance is the game changer. So if you consider this point A, so from A for 2 Newton force, this is the 2 Newton force, perpendicular distance, see, if this is the axis of rotation, this is the axis of rotation, then perpendicular, because line of force is that's why perpendicular distance for 2 Newton is 0. See, perpendicular distance for 3 Newton is 0 and perpendicular distance for 4 Newton. If you move that object 4 Newton, so it would be 2 meter, right? This length is 2 meter. And for 5 Newton, if you extend that object from axis of rotation, it is 2 meter. Okay, 2 meter. Now what is moment? Moment is force into perpendicular distance. Here perpendicular distance is 0, so moment would be 0, here moment would be 0. And for 5 Newton, force is 5 Newton, perpendicular distance is 2 Newton, so it would be minus 10 Newton, because it is in the clockwise direction and we have taken clockwise here as negative, so that's why it is minus 10. And for 4 Newton, the perpendicular distance is 2 Newton, perpendicular distance is 2 meter and force is 4 Newton and it is anti-clockwise direction, and anti-clockwise we have taken positive, so that's why it is plus 8 Newton meter. And if we now the second case is an axis through O and perpendicular to the plane of the square. Now our axis is passing through O. So if you kindly see, this is the square, so that means diagonal bisect each other, that means individual distance is 1 meter. That's why see here this perpendicular distance of each of the forces, perpendicular distance of each of the forces, this is the perpendicular distance. Perpendicular distance of each of the forces is 1 meter. Okay. So what would be the moment? Moment is force into perpendicular distance. So force into 1, F into 1, and this is going in this direction, so this is anti-clockwise. this is clockwise, so this is minus 5 into 1, that is minus 5 Newton meter. This is your 3, for 3 meter it is trying to rotate in the clockwise direction, so it is negative minus 3 into 1, that is minus 3 for clockwise rotation. And for 4 Newton, it is trying to move the object in anti-clockwise, so it is 4 into 1, that is plus 4 Newton meter. Now we will move forward to our next topic. So let us see our next topic, that is coplanar forces is in equilibrium. If the coplanar forces is in equilibrium, then what you have to do, you have to make 3 things equals to 0, that is x component, all the forces of x component should be 0, all the forces of y component should be 0, addition of all the y components, and the moment about any axis, this is tau any axis, that means moment of force about any axis should be 0. This thing is extremely important. Let us apply this concept to solve this type of sum. Let us say this is a ladder or rod. So if this rod is attached to this plane and this surface is rough, that means it should have frictional force. This surface is smooth, that means it don't have any frictional force. So if the rod is in equilibrium, it is given that the rod is equilibrium. Find the frictional force at A, normal reaction at A and normal reaction at B. Let us redraw the diagram. So here we can see that the object is touching the point B, that means it should have normal reaction in B towards the object. Now here at A point we have normal reaction force NA. Now if the object will try to move towards the right side, then our frictional force would be in the left side, that means FA is in the left side. And as in the it is given that in the question it is given that the rod is uniform. If the rod is uniform, then our weight should act from the middle point, that is through the center of gravity. So our weight acts through the center of gravity. So let here the length of the rod is 12, and as usual anti-clockwise moment is, we have taken here anti-clockwise moment as positive. So we have to make 3 things, that is first of all resolve x component equals to 0. If you see the x component, then we have this NB as x component acting right hand side, we have FA in x component acting left hand side. So if we make summation of Fx equals to 0, that means NB is in the right hand side, so NB minus FA should be equals to 0, that is your Fx equals to 0. So NB equals to F of A. Now F of y equals to 0, see the y components, this is your NA acting upward. So see here you have to make the component along y axis, summation of y component should be 0, that means in the NA is acting upwards and W is acting downward. So NA minus W should be equals to 0, that means NA equals to W. Now in the third point we know that we have to make the total moment about any axis should be 0, total moment about any axis should be 0. So we are taking this moment about the point O, that means our axis is passing through the point O. So summation of torque, that is moment of force, equals to 0. So for moment of force or torque, we know that we need force and perpendicular distance. So if you see here force is NB, here force is NA, here force is W, and perpendicular distance from this axis which is passing through O, the distance, how to find that? See, the total length is 12, that means this length would be your 12 cos 30 degree, as this attached to angle 30 degree. Now what is the perpendicular component? This distance, you need this distance NB. What is the distance? This perpendicular component would be NB. If this is 30 degree, then this angle should be 30 degree. So if it is 30 degree, then this is the perpendicular component, which is NB sin 30 degree. Now see, we need another component, that is W. Now if this is 90 degree, this is W, and this angle, that means we need this length, total length is 12, that means this length would be L cos 30. Now let us add all the components. So anti-clockwise moment we have taken here as positive. So for NA would be anti-clockwise, that's why it is positive. So NA is the force multiplied by perpendicular distance. What is the perpendicular distance? 12 cos 30. Now NB will try to rotate the object in the clockwise direction. So anti-clockwise is positive, so clockwise would be negative. So NB is the force and distance is the NB sin 30. So minus NB into 12 sin 30. 12 sin 30. This is not NB sin 30. This is 12 sin 30. 12 sin 30. And now our W, this distance is your this angle is theta. This angle would be theta. So our L cos 30 would be the perpendicular distance. So W into L cos 30, and it is in the anti-clockwise. This is in the clock. You need this distance. So this is L cos 30. So it is minus. So minus W into L cos 30. Now resolve. Put the values of cos 30, sin 30, and cos 30 here, and solve these three equations. You will get Fa would be root 3 by 2 multiplied by W. Na we already got that Na equals to Nb equals to W. Then we have to find out. So okay, let us see how to solve this. This is root 3 Na, and Na is W. So root 3 W minus Nb is Fa. Nb is Fa minus root 3 by 2 W equals to 0. So that means our Fa would be root 3 W minus root 3 by 2 W. So that would be your, if you take root 3 W common, that is 1 minus half is half, that means root 3 by 2 W. So Fa is root 3 by W. Fa is root 3 by W. So if you put Fa equals to root 3 by W, then your Nb component would be root 3 by W, same as this, and Na is your W. Na is W. That's it. Na is W. So let us move forward to our next topic. So let us see if the forces are concurrent and coplanar. If the forces are concurrent and coplanar, then you have to follow only two conditions. That is summation of Fx you have to make 0, and summation of Fy you have to make 0. Why? Because see this example. If the plane, if your axis of rotation is passing through this point, then all the forces or line of action is actually attached to that point. So perpendicular distance would be 0. So here in this, for concurrent coplanar forces, you don't have to make the summation of torque or moment of force 0. So here for concurrent forces, you have to make only Fx0 and Fy0. Let us see one question. An object is in equilibrium under 4 concurrent forces in the direction is given. Find the magnitude of F1 and F2. Here this angle is given 30 degree. This is 4 Newton. This is F2. This is F1. This is 8 Newton, and angle is given as 60 degree. So very simple, right? Because we have to make summation of x-axis forces to 0. So see, this 8 Newton is in the right hand side of x-axis, so it is positive. And if you see this 4 Newton, so what would be the component along x-axis? It should be 4 cos 60. Okay, so that's why it is in the right hand side. So 4 cos 60, 4 cos 60, yes, and F2, oh sorry, 4 cos 60, right? Oh, this is Fy0, 4 cos 60, and for F2 it would be in the negative x-axis, right? It would be F2 cos 30 degree, and in the negative x-axis, so it is minus F2 sin 30, cos 30 should be equals to 0. Now solve, you will get F2 equals to 20 by root 3 Newton. Now in the y-axis, in the y direction, see we have F1 in the positive y-axis, so F1 plus this 4 Newton. If you resolve, this is 4 cos 60, and this component would be 4 sin 60. So it is in the upward direction, so it is positive. And for this component, our perpendicular component would be F2 sin 30, and it is in the negative y direction. So minus f2 sin 30 should be equals to 0. Now solve, you will get f1 equals to 4 by root 3 Newton. Now see, Lamy's theorem we have already discussed in our board level lecture. So what is Lamy's theorem? If there are three concurrent forces f1, f2 and f3 making angle alpha, beta and gamma, then we know that this f1 divided by sine of opposite angle, that is sine alpha, f2 divided by sine beta and equals to f3 divided by sine gamma. This is your Lamy's theorem. This is your Lamy's theorem. Now let's see one question regarding Lamy's theorem. One end of a string 0.5 meter long is fixed to a point A, this fixed to a point A, and the other end is fastened to a small object of weight 8 Newton. That means this is weight, this object having weight 8 Newton. The object is pulled aside by a horizontal force, that means you are pulling that object, this object, horizontal force F, until it is 0.3 meter. That means this distance is given as 0.3 meter. This distance is given as 0.3 meter. The length is given. So AC we already know 0.5 meter. So this is 0.5 meter. This is 0.3 meter. Now it's a right angle triangle. Apply Pythagoras. You will get AB as 0.4 meter. Now let us say this angle is theta. So this angle would be, draw a perpendicular. This angle would be also theta, alternate angle. This is a transversal, right? So what would be the cos theta here from this diagram? Cos theta would be base by hypotenuse, that is AB by AC. AB is 0.4, AC is 0.5, so 4 by 5. Now what would be the sin theta? Perpendicular by hypotenuse or opposite by hypotenuse, that is BC by AC. BC is 0.3 and AC is 0.5, 0.3 by 0.5, that is 3 by 5. Now apply Lamy's theorem. See here, F divided by opposite angle. Now see here, the forces are only, let us remove this. Here forces are this is one force T, this is another force F, let us erase this, and this is your another force 8 Newton, and all of the three forces are concurrent. So that means we have to take this angle between these two forces, this angle between these two forces, and this angle between T and F. So what would be the angle? This, if this is theta, total 180, so this angle would be 180 minus theta. So F divided by sine of 180 minus theta. Now let us say 8. That means you have to take opposite angle. So this angle is 90 degree. This is theta. So whole angle would be 90 plus theta. So sine of 90 plus theta. And if you see, and this is your T. This force is T. So opposite angle would be, opposite angle between F and 8 Newton is 90 degree. So T by sine 90. So sine 90 is 1. So T equals to 8 by sine of 90 plus theta. So it should be cos theta. And this is F by sine of 180 minus theta. Equate this, you will get three equations. One is equate this thing to this thing, this thing to this thing, and this to this. Three equations you will get. By solving three equations, you will get T equals to 10 Newton and F equals to 6 Newton. So let us see one problem related to hinge. The rod shown in the figure has a mass of 2 kg and the length 4 meter. That means this length is 4 meter and the mass is given as 2 kg. In equilibrium, find the hinge force acting on the rod and tension in the string. So you have to find T and you have to find hinge force. Let us say F is the hinge force. Now see, we have just discussed in the previous slides that if we have a hinge, the hinge should be resolved in two components. One is horizontal force of the hinge and another is vertical force of the hinge. So this is the horizontal force of the hinge given to the rod, and this is the vertical force of the hinge given to the rod. Now this angle is given as 30 degree. Now see 37 degree. Now see, always remember we have already discussed this thing that sine 37 is always 3 by 5 and cos 37 degree is your 4 by 5. Remember this because it may create a problem. Now see, this is a string. So string is always towards the attached point. So this is the tension T towards the attached point. This is attached point, right? Now see, if we break this forces in this diagram. See, this is the hinge, this is the vertical component of the hinge force, this is the horizontal component of the hinge force, and this is the uniform rod. So the weight will act from the middle. So this length would be 2 meter and this length would be 2 meter. Now if you resolve this 37 degree, this component would be t cos 37 degree as it is attached to the angle, and this component would be t sin 37 degree. Now here we have shown separately. This is t sin 37 degree and this component is t cos 37 degree. Now cos 37 is 4 by 5, that is 0.8. So 0.8 t, and so this component is our t sin 37 degree, that is 0.60, because this is 3 by 5, that is 0.6 t, and this is your t cos 37 degree, that is 4 by 5, that is 0.8 t. Now we know that in order to solve this type of problem, notice one thing, that this force T, this force H and this force V, they are not concurrent. For concurrent forces only we will make summation of Fx0 and summation of Fy0. As these forces are not concurrent, then we have to make torque, summation of torque equals to 0, that is summation of all the moments should be 0 for equilibrium, as far as equilibrium is concerned. Now summation of Fx0, so what are the x components, that is this is 0.8 t, that is t cos 37 in the negative side, and this is h in the right hand side. So h minus t cos 37 should be 0, so we will get one equation. And if we make summation of Fy0, then in the upper component we have 0.60, in the lower side we have 20 Newton. See, the weight is, mass is 2 kg, so mass into acceleration due to gravity, that is W equals to mg. So m is 2, g is 10, let us say, so this is 20 Newton. So 20 Newton minus 20 is acting downward and V is acting outward. So V. So V plus 0.60 minus 20 equals to 0. Let us say that is the equation number 2. And summation of moments, force of moments, tau equals to 0. So here in this case, clockwise torque given by this 20 Newton, is balancing with anti-clockwise moment given by this 0.6 t. We don't have to take V, H and 0.8 t, because V is passing through the point of application, point of axis, right? This V, we don't have to take this. This H also passing through the axis, so we don't have to take this. This component will also passing through the axis. Now we don't have to take this 0.8 t. We have to take only 0.60 force. This is force into perpendicular distance, which is 4 meter, force into perpendicular distance, which is 4 meter, and we have to take this force, that is force into perpendicular distance. What is the perpendicular distance? 2. So 2 into 20 should be equals to 0.60 into 4. Now solve this equation, these three equations, you will get tension as 16.67 Newton, H as 13.33 Newton and V as 10 Newton. Now see, if this force is H, hinge force, and this vertical force is V, so this is H, this is V. So what is the resultant component? Resultant component will be root under of a square plus b square plus 2ab cos theta, as it is 90, so we have to only find root under of h square plus v square. We know H, we know V, put, you will get 16.67 Newton. If they ask about the angle by which the hinge force, the resultant force is acting, then you have to make tan theta, which is perpendicular by base. So 10 by 13.33, that would be 37 degrees. So see, in the laws of motion, it is all related to FBD. We have just seen. Here you have to remember 2 to 3 points extra. That is our, if there are connected bodies and if you want to find the motion of that object, then summation of Fx you will make mass into acceleration, that is acceleration of the whole system, and mass is the total mass of the system. So Fx equals to mass into acceleration. If the system is in equilibrium, then you have to make Fx, summation of Fx0 and summation of Fy0. If the forces are collinear, then you don't need this component, you have to make only summation of Fx equals to 0. If all bodies of a system has a common acceleration, then this is very useful formula, you can use this, that is acceleration is net pulling or net pushing force divided by total mass. See this system, in this system this is the same rope, and acceleration, so it has the acceleration A. It is frictionless and massless, that's why the whole system has the tension T equal, and this is 2 mg and this is mg. Now what is the net pulling force here? Net pulling force, that is here 2 mg is acting downward, here 2 mg is acting in opposite direction. So what is the net pulling force? That is 2 mg minus mg, that is mg. So mg by total mass, what is total mass? 2m plus m, that is 3m. So g by 3 is the acceleration of the whole system. Now let us see another question. Here 3 blocks are attached to one another, mass is 3 kg, 2 kg and 1 kg, and you have applied a 12 Newton force to the 3 kg block. You have to find the net force on 2 kg block. You have to find net force on 2 kg block. That means this block. You have to find force on 2 kg block. Now see, summation of Fx, we have already discussed that you have to make summation of Fx equals to mass into acceleration. So that means acceleration of the x component. So here total force is 12 Newton. This is summation, that means total force. Here we have only one force, that is 12 Newton. So 12 equals to, and this m is total mass. So what is total mass? 3 plus 2 plus 1, and we let us say we have assumed that acceleration of the whole system is A. So if you make this one block, as a system, so this system has acceleration A, mass is 6 kg, and you have applied a 12 Newton force. So 12 Newton force equals to mass into acceleration. So from this you can get acceleration as 2 meter per second square, or we have just discussed that you can find acceleration of the connected bodies by using this formula, net pulling or net pushing force divided by total mass. So acceleration is net pulling force by total mass. So acceleration is net pulling force by total mass. So what is the net pulling force? Here pulling force is in the x-axis, there is only one force, we have 12 Newton divided by total mass. What is the total mass? 3 plus 2 plus 1, that is 6. So you will get the same acceleration. So either you can find by this method, that is summation of Fx equals to mass into acceleration, or you can find out this acceleration by this formula. Now see, let us say here F force is applying on 2 kg block. So from this formula summation of Fx equals to mass into acceleration, we have just found out the acceleration. Acceleration is 2 meter per second square, and what is the mass? Mass is 2 kg. So 2 into 2, that is 4 Newton. That means 4 Newton is applying on 2 kg. You can find out the force of 1 kg. So 1 kg force on 1 kg block would be 1 into 2 meter per second square, that is 2 Newton, and force on this 3 kg would be 6 Newton. Okay. So let us see another problem. Here 2 blocks are attached with a string with another block C with a pulley, and mass, this pulley and the strings are massless and frictionless, and this A block has mass 1 kg, this B block has 3 kg, and this C block has mass 2 kg. The question is the acceleration of the, you have to find the acceleration of the system and tension in the string. Okay. Now see, as the strings are massless and frictionless, the acceleration can be assumed as same, that is acceleration is same for all the objects. Now we have just seen that acceleration is net pulling force or net pushing force divided by total mass of the system. So what would be the net pulling force here? See, we have learned in the board level lecture that this angle is 30 degree. That means our mg, that is 2 mg, would be acting perpendicular to the ground. So this component, this angle would be 30 degree. So this would be 2 mg cos 30 degree. This would be 2 mg sin 30 degree. Now let us concentrate on this. This is 3 kg, so this would be your 3 mg. So this angle would be your 60 degree. So this would be your 3 mg cos 60 degree, and this component would be your 3 mg sin 60 degree. Now see, apply the same concept. This is your mg, 1 kg, that is mg, and this is your 60 degree. So this would be your mg cos 60 degree, and this component would be your mg sine 60 degree. So clearly we can see that net pulling force here, net pulling force is 3 mg sine 60 and mg sine 60. 3 mg sine 60, let us say this mass is for A, so 3 mg sine 60, and let us for B, so mvg sine 60. So our net pulling force would be mg sine 60 plus mvg sine 60 minus this block is trying to pull that object in that side. So it would be minus this, let us say this is C, so 2 mcg, let us say this is 2m, let us say this is mcg sine 60 and mc is your 2m. Here let us say mv is your 3 mg and here ma is your 1 mg. Okay, so mag sine 60, mag sine 60 plus mvg sine 60 minus mcg sine 60. So that this is your net pulling force. So put all the values, calculate, you will get net pulling force would be 24.64 Newton. Now acceleration would be, as the system is as this spool, this pulley and the wires are massless and this string is extensionless, inextensible and frictionless. That's why we can assume that acceleration is same. Acceleration is same here. So acceleration would be net pulling force divided by total mass. What is the total mass? 3 plus 2 plus 1, that is 6. So you will get 4.1 meter per second square. Now see, next question is find the tension in the string. So what would be the tension? Let us say this tension, I have already told you that tension is always towards the pulley. Let us say this tension is T2 and this tension is T2. So you can draw the FBT of C in order to find out the tension. So here T2 is larger because this mass is larger, so whole system is going in this direction. So T2 is larger. T2 minus opposing force is mcg sine 60. T2 minus mcg sine 60 should be equals to mass into acceleration, because why? Because we know that summation of F equals to mass into acceleration. We have applied this concept here. So T2 minus mcg sine 60 should be equals to mass into acceleration. Mass should be for mass of the block C. Now take that whole term, put all the values, you will get 18.2 Newton. In order to find out the tension T1, let us say this is the tension, this is the tension T1. In order to find the tension T1, you can draw the free body diagram of A. So T1 is acting away from the block, and this is your mag sine 60, mag sine 60, and the object is going downward. So mag sine 60 is larger than T1 as the object is going downward. So mag sine 60 minus T1, this is the resultant force. This resultant force should be equal to mass into acceleration. So mass of the object block A into acceleration. So take the whole thing in the right hand side, put the values, you will get 4.56 Newton. I hope you are enjoying our lectures, and in the next topic we will see constraint equation. We will start from there in our next JEE lecture. Today we have completed 100 subscribers. Thank you all for supporting us. Keep supporting us, and all the best. Thank you.
Once more.